Good evening. Welcome back to the Thermodynamics lecture 3 basics intermediate. So in the thermodynamics we have seen open system, closed system, isolated system, first law of thermodynamics, maximum work done, and enthalpy. Now we will see some more basics. One is the extensive property and intensive property. What is extensive property? It is a property of a substance. Extensive property is a property of substance whose value is depends upon quantity. Extensive is depending on depends on quantity of the substance. That is example, volume, mass, internal energy, that is delta U, enthalpy, what we have seen, enthalpy, heat capacity. This was not studied, we will study heat capacity. Then what is intensive? Intensive is INTENSIVE, intensive property. Just opposite, that means a property which doesn't depends on quantity. It does not depends on quantity. Example, temperature, pressure and density. So these two are the normally we require most of the time. Then comes to the heat capacity. Because why this is required? Thermodynamics, after some time it will become thermodynamics, will become thermochemistry. Most of the reactions we are dealing. So in the thermochemistry, heat capacities are mostly widely used, particularly the gases and all. Right. So now what is the heat capacity? Heat capacity is required for any system. If we are giving the heat Q, when we are giving Q to this system, what will happen? Its temperature gets increased or it is proportional. If it is less Q is taken out, it will be decreased. If it is Q is increased, delta T is, that means it is directly proportional. If I am removing the proportionality, it is called C delta T. C is a capital C, remember? C is nothing but heat capacity. Then what is the heat capacity? Before going for heat capacity, it is a coefficient, it depends upon what? Nature of the system, size of the system, nature of the system, size of the system, composition, so on and so forth. And if C is more for a given amount of Q, delta T will be less. More clearly, suppose I am giving a heat to three, one is alcohol, one is kerosene, and another is water. Whosoever substance is having more C, their increase in temperature will be less. The total product is nothing but it is a constant, whatever we have given. So water heat capacity is more. Water heat capacity means carrying capacity. The water heat capacity is more. So in this one more small is molar heat capacity, CM. CM is molar heat capacity is heat capacity by number of moles. Very simple. N is the number of moles. That is called heat capacity, molar heat capacity, number of moles. Right. There one more term. This is heat capacity. One more term is the specific heat. Just the same as the heat capacity, but there is small change. That is quantity of heat required. Listen carefully, required for 1 degree raise to for 1 gram, for 1 gram substance. That is, Q is nothing but small c, here is the big C, into m mass into delta T. Is nothing but, this 2 is nothing but big C, C delta T. So specific heat is nothing but quantity of heat required to raise the 1 degree centigrade for 1 gram substance in a system. That is the specific heat. Now some more terms we will see, that is the Cp and Cv. Cp and Cv. Right. What is Cp, what is Cv, and what is their relation? Now Qv is Cv delta T. Cv delta T is nothing but delta U internal energy. Similarly, Qp equal to Cp at constant pressure, at constant volume, heat capacity at constant volume, heat capacity at constant pressure. Just it is nothing but delta H. Then if we see delta H minus delta U equal to delta PdV PV. Delta PV I can write as PV equal to nRT. Delta nRT is nothing but nR delta T. Delta H is nothing but Cp dt, Cv dt is equal to. So if I am cancelling the others, all the sides, delta T, Cp minus Cv equal to nR. R for 1 mole, it is Cp minus Cv equal to R. This is the relation between Cp and Cv, the most important one. Cp minus Cv equal to, for 1 mole, it is R, Cp minus Cv. That is the relation between the delta H. Indirectly, it is nothing but delta H minus delta U equal to R. Okay, how to measure the delta U? That is by bomb calorimeter. Bomb calorimeter very simple, so nothing to mention much. Bomb calorimeter for the measurement of delta E, that is delta U, internal energy. And similarly, that is at constant volume. Similarly, we can measure the delta H also by the pressure constant method. Right. Now, the last one we will see today is enthalpy change or reaction enthalpy or enthalpy in the during reaction. What do you call? Enthalpy change. Enthalpy change in a reaction. Meaning is, say, what is normally reactants use products. This is the reaction. So products enthalpy minus reactants enthalpy is nothing but, it is enthalpy of a reaction. Simple example we will take, then it will be very easy to understand this thing. Normal general in this thing is methane gas reacting with oxygen gives carbon dioxide plus water. 4 means 2 oxygen, then 2 oxygen is sufficient, plus 2, so 2 O2. This is the balance. Always balance the equation, then only you write. So now what is this thing, enthalpy change in the reaction is the reaction enthalpy is products. These are the products enthalpy minus reactants enthalpy. That is nothing but the reaction enthalpy. Reaction, that means the delta R reaction enthalpy, delta R H is enthalpy. If I am taking CO2 enthalpy, means I will write like a H molar enthalpy of CO2, only a single CO2. So plus 2 molar of the water enthalpy minus enthalpy of the CH4. This is a total minus I can write, or the individual minuses also. Total minus I will write 2 molar of the 2 HM of the O2. That is the reaction enthalpy. Reaction enthalpy is nothing but products enthalpy. Some of the some figures, some books it will be a sigma, sign is used for the summation. Sigma is like this. So that is nothing but products enthalpy minus reactants enthalpy. Then standard enthalpy also similar to this, but that will be at 25 degrees centigrade. That is nothing but 298 degree Kelvin. Otherwise, the same this thing. And 1 atm. Always remember that everything will be at the fixed temperatures and fixed pressures. So standard enthalpy also is defined. Standard enthalpy is nothing but enthalpy at for a pure substance at 298 degree Kelvin and 1 bar. So tomorrow we will see the enthalpy changes during the phase change. Phase change means high water, ice to water, water to steam and all. Okay, thank you very much.